Hello YouTube, welcome back to the LooseTransistor Channel. I'm your host Lucas, and today I'm bringing to you part 3 of my build and review series on the Detroit Multirotors prototype frame, the WP17. So in the last 2 videos we covered the parts that are going to be going in this build, and on the previous video we covered the assembly of the frame and the dry fitting of the components and how everything was going to fit together. So today we're going to be actually doing the nitty-gritty of the build. We'll be putting everything together and soldering it and getting it to the point where it hovers. In the next video we will be doing the tuning and flight impressions on the frame, and later on, maybe a month or 2 down the line when I've had a chance to really crash this thing, I'll give you guys an overall impression of the frame and its performance and how it held up over time. So yeah, let's just get started with the build here. As I mentioned before on my previous video, we're going to be using the Omnibus F3 AIO board that comes with a built-in OSD with a Betaflight, and you can use the Betaflight tab to configure it. It has a current sensor, and the OSD is quite nice, and I actually quite like the flight characteristics on this board. It can easily run 8 kHz, 2 kHz PID loops, and it has a nice little SD slot so you can put a SD card and get your like gigabytes and gigabytes of flight logs if that's what you're into. So I mentioned in my previous video that we were going to be using this little TPU bit to build the stack because we wanted to isolate the daughter board from the frame, and we need to keep the build very, very, very short because these side plates right here that are made out of TPU and sit right over there like that, they hold the camera in place, and if your stack is too tall, it'll start pushing against that and bulging it out, and then you won't be able to get your camera in place. So what I ended up sorting out is that 20mm screws are about the limit. You can maybe get 22, 23 out of this and just be barely touching there, but I wanted a little bit more clearance, so I went with 20. We're going to be using the 20, and instead of this little TPU bit, I actually found this thing here, which is just a piece of fiberglass. It's non-conducive, and it's about a 0.5 millimeter thinner than this guy here, which will allow me to be a little bit more comfortable on the build by just a tiny bit. First, you need to solder in the pin headers that are going to go in this guy. So I have some pin headers here. Just want to be certain that the height is sufficient between the two. So we're going to be using 2 nuts to hold the stack together and to space the flight controller from the PDB. So I just want to make sure that that's still a good idea. And if I'll get enough bite to actually solder the two together. Okay, so that's roughly the height that I would need. Oh yeah, we got plenty of room, so this is going to work out perfectly. So before we apply the drone dry and make this thing waterproof, I should solder the pin headers on, because we're gonna need these to transfer the signal pins from the motors from the daughter board up to the flight controller. And this is exactly how we want them. Excellent. Yep, perfect. Okay. So I'm cutting the pin headers in groups of 3, so that's what you're gonna need. So it's basically a signal pin, a 5-volt pin, and a ground pin. You could do away with the middle pin, but I mean, it's so much easier to solder them in a group like this, so I'm just going to keep them together. Need 4 of these. Excellent. I should probably warm up my soldering iron. So while that warms up, I'm going to get us set up here. Alright, the jaws of justice. They're here, finally. Okay, so let's get cracking on getting those mounted. So this is going to be the top of the daughter board, and you can tell because it mates perfectly with the FC this way, and the battery plus and the VCC are to the rear, which is where you're going to connect the battery plus and the ground to make them paralleled and to feed your ESCs. So this is the correct orientation. So you have to make sure that it is this direction, and that group of pins lines up with this group of pins right here. So since this is the top, I'm actually going to solder through the bottom first, and I'm going to tack on these little pin headers and just one spot so that I can move them and get them nice and flat and nice and even. So here we go. So basically the idea is to come here. Actually, I'm going to do it slightly sideways first. So I'm just going to tack on that rear pin right there, just enough to just hold it into place, and I'll do all three, and then I'll come back and I'll adjust them so that they're nice and flat, and then I'll solder all the pins. So let's see how my soldering iron is doing here. Perfect. That didn't take very long. Okay, so just like that, I put one pin and I just slid it forward and pressed it against the daughter board so it sits nice and flat, just like that, nice and straight. So that's important because it'll make your life easy later on when you go to mate the two. So let's move on to the second pin. Now this one should be a little bit easier because you can kind of brace it against the one above it. So it might be a little tiny bit easier. Not straight enough. I'm gonna flush, nice and flat. Okay, just like that. Looks to me like they're seated quite well. So as you can see, I just did those pins, nothing else, and just barely. Let's see how well it mates with. Yep, that's good. So we have good meshing. They fit very nicely. They slide very easily, so we're pretty much good. So now let's just finish the soldering down here, and we'll clean it all up. Alright, so basically we just finished tacking all these on, and I'm just going to go back and just reflow them a little bit. Make sure that we have really solid connection, because this is what is going to be powering your ESCs, giving them signals, so you want to make sure that's a really good connection. Just a quick little reflow. Okay, just like that, we got the pins soldered. So now we're just gonna clean up this stuff as best as we can. Okay, we got it pretty close to flush. However, as I mentioned before, this thing needs to sit pretty much flat on top of that little fiberglass piece. So even just that little bit is gonna cause it to lean a little bit. So I'm gonna try to mitigate that a little bit by just doing some very quick filing here. Okay, so now that we sanded it down a bit and made it pretty much as flat as it'll go, I'm going to hit it with some alcohol and clean it up just like we did with the ESCs last time. So just to remove the flux that goes on the solder, which is not good for your electronics, we covered up. Cool, so let's just do that real quick here. So now we have the daughter board with the pins all soldered and flattened out a bit. I just sanded them down a little bit with a diamond file, and the pins all ready to go here, and it mates with the flight controller just like we wanted to, so that's perfect. So I'm gonna mount this to the frame, and we're gonna start soldering stuff to it. Okay folks, so we've gotten the daughter board mounted on top of that little fiberglass piece like I told you guys about, and the pin headers are facing forward towards the direction of travel that I want this drone to go in. I've got the 20mm screws and the 2 standoffs set up, and now I'm basically just trying to figure out spacing as to, because you have to run a ground wire for the battery and for a positive for the battery as well, but you also have to run a ground that goes and shunts into the PDV. And the way they have it here is they just have a very large ground pad right here, so it makes it a little bit tricky. I'm basically going to start wiring the battery leads from the flight controller, and also figuring out the VCC leads and how long they need to be. That's an important step on doing the F3 AIO with the daughter board, because as I said, they're kind of parallel to each other. It's an unconventional type of build, and I don't mind it. Once you do a few of them, you kind of get used to it and you just kind of deal with it. First couple times that I did it, it wasn't great. So basically you're taking a positive lead, this is going to go to the battery, and you're going to solder it right there on the bat plus, tin the 2 pads and get them ready to receive some wires. The AIO, the Omnibus F3 AIO is pretty resilient and robust. You don't have to worry too much about heat or anything like that. We're just leaving some nice big fat gobs of solder here. There we go. Cool. And that was the ground pin right there that I also just put a bunch of solder on it. Be careful with this ground. It has very close to some very, very small surface mount. So just be cognizant of that. Be careful. Okay, so let's tin the ends of the battery wires, because that helps get everything soldered more easily. And I'm kind of like to strike while the wire is still hot, so I'm gonna get the lead soldered on here. It's absolutely fine if your solder bridges on top of that surface mount current sensor. That's what it's there for anyway. They kind of expect that it's going to happen, so don't worry too much about it. We're going to come back and put some more solder on this afterwards and really secure this down. So let's put some solder on this guy here too. Okay, so we've gotten that bit soldered. So bat plus and the ground, we're good. We're going to be putting another ground cable in there, but we're not going to worry about that just yet. First, what I'm going to do is I'm going to put a little piece of something they won't tell you, but it's a little trick I learned building these. Put a little piece of tape and hold these 2 together so that they don't move, and then you can come back with the soldering iron and just like reinforce that area a little tiny bit. So just reflow the solder a little bit, and looks really nice, and I give it a little bit more space so that I can put the other negative lead in there. So after I do that sort of stuff, I always like to test and make sure that I didn't screw stuff up and that my connections are good. So what I do is I use my variable power supply here, and I set it to about 15 volts, and I plug it into these guys right here that I just spliced, and we'll see whether or not it powers up. That's 1. That is 2. And we have contact. So we're perfectly good on the battery leads. We're good to go. So what we're going to do next is get the 2 shunt cables prepared and soldered to the FC first. We're going to solder it to there last, and then we'll get the ESCs all set up, and we'll go from there. So just hang tight, and we'll be right back. Alright guys, we're back. Sorry about that. I just had to go out and fly. It was just way too nice out there, and it hasn't really been nice out here in the past few weeks. Haven't gotten as much flying as I wanted to, and I wanted to do some tuning to my Garuda. It's getting pretty close now to how I want it to fly. Still a little bit of wobble here and there, but we will get there. So for now, let's worry ourselves with what we're doing here. We're continuing assembly of the WP17. Last thing we did was get the battery wire soldered. So I'm gonna now put the VCC cable on here as well as the second ground lead, and I'm going to figure out how I want those two to come out. What I'm going to do is I'm going to put the the ground lead underneath like this, and then just do a really quick little bend with it, kind of like that, and then tack that to the bottom of the plate right there, so I'll be able to fold it over and get it on there. So it's a little bit extra wire than I want to use, but like I'm not really too concerned right now. Right now I just want to get this thing flying. So let's do the easy part first, which is to add the VCC cable to the top. So I'm going with the same battery gauge as I'm using here. I don't have any 14 on hand. That's just too bad. It'll be fine. I've done this in my other two builds and I had no problems with this configuration. Another important thing to make sure you keep in mind when you're building on the omnibus is that you don't solder this wire too far to the left and block that little nut hole right there. It has a drawing on the actual board that shows you how big a standard nylon nut is, or a nylon standoff. So you really want to try and get away from that line and not be over it. Though if that does happen, you can usually just go in with the shears like these ones and just straight up just shear it right off. It usually works out fine. This time I was much more careful because I knew what to expect, so I tried to move it up to the right a little bit more. So it's pretty simple on this one. The VCC pad is pretty big. You don't have to worry about connecting it to this thing. Again, if you bridge that gap, it's not a big deal at all. It's totally fine. That's just a current sensor, so that's basically all it's doing anyway, shunting the two. Okay, so that's basically what's going to go down here. Is we're going to have this folded over and then soldered over there. Sort of like that. Not going to worry about cutting this just yet. I'm going to leave it as it is. We're going to now put on the second ground that is going to go right next to this ground, and it's going to be sort of the same situation here. We're just going to have it going straight out, and then I'm going to do a little bend, and I'm going to attach it right there. And as you might notice, I still left the tape there because I don't want to I'm probably going to melt the whole solder to get a nice joint there, and I don't want to move that wire. And I can actually use the other wire to kind of hold it together here. Okay, so I powered up the FC and everything's fine. I'll even power it up one more time so you can see that the boot sequence actually lights up on the LEDs. There you go. So I pretty much booted, so I know it's good to go. As I said, the Omnibus is a bit of a pain in the ass to wire, especially this stupid battery shunt system. So now it's a little bit easier for me to illustrate to you guys what's going on. So we have the positive negative from the battery coming here and sandwiching the board that way, so up and down. And then that goes over to the VCC, which feeds our little guy right there. And then we have a ground lead that goes from the FC to that daughter board as well. So it's a bit of an odd setup, and you end up having to use a lot of wires, which is not great. They need to come up with a better system for the Omnibus. It's a great FC in terms of performance. Don't get me wrong, it's great. The OSD is fantastic, but goddamn, it is a pain to set up. So now that I've burnt the crap out of my fingers and I got that soldered up, I can see right there that I went a little bit over too far, and I'm too close to the nut, so it won't really work out unless I do some trimming. Alright guys, so we soldered the power leads to the flight controller. I cleaned it up here. Now with using the shears, I just like snipped off to the side here so that there can be clearance for the lock nut that's gonna hold this in place. And I think there's just enough clearance. I might have to sand it down a little bit, but that's not a big deal. We have the VCC lead that's gonna power the daughter board. We also have the ground for the daughter board, and then we have the leads for the battery. I already tested it. It powers up. We're good to go. I didn't burn anything while we were soldering, even though I almost burnt the crap out of my fingers. So we're going to leave this aside for now, and then we're going to come back to that later after we finish soldering the ESCs to the daughter board. Now we're going to just do the power for the daughter board first and the signal wires later, just because we're going to have to crisscross them a little bit, and it's easier to solder the big wires first and then smaller wires later. Now, so if this is the front of the quad, and this is motor 1, 2, 3, and 4, you'll see, if you at least have it the board lined up the way that I do, that they no longer line up with the writings on the side, and that's fine. However, these writings do correspond to these pins, and these pins are going to line up with the flight controller, so it is important that you move the signal to where it needs to be. I guess you could do the same with motor mixes and anything like that, but I honestly rather do everything hardware side than have software involved in the mix. That's just my preference. So let's start getting the leads for the ESCs cut to size, and we'll start by tinning the whole daughter board, and then we'll get soldering. Okay, as you might have noticed, I'm not sure if you can see from the camera there, but a lot of my solder got sucked under the board. I'm going to take it off from the stand here real quick, and I want to take a look at it and see what that looks like on the underside. And I might heat up the underside to get the solder to flux back, or flow back to the front again. Let's see what happens here. Okay, so the flux actually ended up sticking the two pieces together. So yeah, I'm glad I didn't solder over top of the CPU, because I'm quite sure that would have gone even worse. Overall, not too bad on the bottom here. I'm just going to quickly heat up a couple of the pads, and it'll flow the solder forward and down. Okay, let's just let the board cool off a little bit. Let's get the board back on. This time I'm going to put all 4 screws, and I'm going to put some pressure on it to keep the solder from reflowing underneath. Just giving it a quick tighten here with the Allen key, keep it nice and snug as we solder the wires onto it. And that's just to prevent the solder from flowing underneath the board somewhere. Okay. So before we can solder, we need to cut all these wires and make sure that they are exactly where we need them to be, and then expose the end of the wire so that we can start soldering. Cool. So I'm going to do one wire at a time, and just get going here. So now that I've tinned the wire and I tinned the pad, it should be a pretty easy matter of just heating it all up, and it should join. And it should be nice and easy. There we go. VCC wire, good to go. Let's do the ground. I like to twirl down the cable a little bit too, makes it easier to solder. I know a lot of this stuff is probably elementary to most people listening, but I'm sure there's some people that are listening that have never built a quad before, so I'm going to be dropping some pretty noob stuff as well, and hope everybody learns a little bit as they watch. I'm still learning a lot myself, and even this build itself, I'm learning stuff on it, so... Just gotta try not to burn other stuff as you're trying to build it, right? There we go. Nice and neat. Should still be able to get that net out. Yeah, it's funny, I did the same build on my Garuda, and I could swear to you I was being just as careful as soldering, but it was kind of late, so maybe I wasn't being so thoughtful as I thought I was. And I flew the Garuda and maidened it, and it was perfectly fine, and when I came down to land, it just bounced on the ground a little bit. Didn't seem to matter. It disarmed, plug a new battery in, it won't arm. One motor just simply won't arm. And later I figured out that one of these solders that I just put down had just popped up, just like that. But the pad was fine, everything was fine. It's just like a really weird cold solder. This time I'm trying to be extra careful so that doesn't happen again. And I'm surprised the thing even flew. I mean, that was really, really weak solder. Okay. Just right. I've been forgetting to actually grab some solder too when I go to do this. Should probably help a little bit. It might be easier the other way around. There we have it. So we've gotten all of the power cables set up and good to go for the ESCs. So phase 1 of the wiring is pretty much complete, fellas. Alright guys, I was just about to remove the board and do the application of drone dry to make sure that it's waterproofed, but I just remembered I haven't put the signal wires on. So let's put the signal wires on to the daughter board, and that'll be pretty much the last step of soldering on the daughter board, and then we can move on to the rest of the build. So because I rotated the daughter board and the FC 90 degrees, the motor pinouts don't line up anymore. So I just have to check out here and see where I'm supposed to put these, and we'll get going. So motor 1, 2, 3, and 4. So motor 1 is actually down here, so this guy's going to come here. And motor 2 is across. So motor 2 is going all the way across over here. So just so I have that in mind there. So motor 2 goes all the way across. So motor 1, and then motor 3 is also all the way across, and motor 4 is going to be all the way to the bottom. Okay, so let's get started with the soldering of the signal wires. I'm going to come from the outside with the signal wires, I think. Or maybe should I route them? Yeah, actually I'm going to route them inside. Make it a little bit cleaner. So, okay, I'm not too worried about it being super short or anything like that. I am going to be using both the signal and the ground because I find that to be a safer option. I've had less problems on my builds that have had ground than on the ones that only have the signal wire. Now, I don't know if that's just bad luck or this or that, it doesn't matter, but from now on, I do the actual both wires if I can. Okay. We need a whole lot of wire exposed. Just a tiny little bit. So in case you're not familiar with wiring ESCs, in this case the DRS and most ESCs out there, the lighter color or the brighter color usually indicates that that is the signal lead, and then the darker color or the bluish color usually indicates a ground, and so that would be our ground. Our soldering should be hot enough now. Yep. So it's always good practice to tin your wires. This makes it easier to solder in. Save you a little bit of time. Makes for a nicer joint. We already have tinned the pads, so we don't have to worry about that. So motor 1 going on pin 1. These wires that come on the cicadas and on the DYSs seem to melt very easily. I'm not the biggest fan of these wires, but I'm also not going to be replacing them right now. Just like that, very quick. Doesn't take long at all. Good. Good. So motor 1 is done. Now we're going to do motor 2, which is across, all the way across. We're going to route it thusly. Probably shouldn't be doing this while holding the soldering iron. Okay, so that's going to have to go right there. Cool. See, the wire just disintegrated. Go figure. It's going to be fine. I'm going to hit the whole thing pretty much with drone drive very shortly, so it's not going to be too much of a problem. And then finally, motor 4. My least favorite motor. Seems to be that when I get desinks, it seems to be that motor. I'm sure there's no actual reason for that, and I'm just being paranoid, but... Right, let's go through the inside as well. So this is ends up being very similar to how I built my Garuda. And the Garuda ended up being a fairly tight build too. The omnibus is not really compact. I wouldn't call it compact. If you want something super compact, you're looking at an HDLRC or a Combini, something that has both the flight controller and the ESC power pads on one board. And I really hope they come out with something like that for the omnibus because the flight performance is pretty damn great. Nice. Okay, so we got the signal wire and now just the ground. And that is it for wiring the daughter board. We've done it, guys. Gotten the daughter board wired. Okay, let's take a quick look here. So our little octopus guy here is all wired up. All the signal wires have been crisscrossed to correspond to the proper position of the motor respective to the new orientation of the flight controller. So we have the power leads are all good to go. This should pretty much boot up now once I get the two boards put together. So what we're going to do now is basically clean it off with some isopropyl alcohol and make sure that we have a very nice clean surface so we can apply the drone dry. I'm literally going to be putting this shit on everything, and I already do. All my quads in my last few builds all have had drone dry. I've already gone through probably 2 vials of this stuff, and it's totally worth it. I feel confident flying my quad around even in the rain, or if the field is wet and I don't want to crash because there's water. Nope, doesn't matter. Get yourself some drone dry. It is available at beaverfpv.com. Make sure you check out beaverfpv.com as well. Those guys are freaking fantastic. I was just over there today actually, and yeah, we're going to be applying this on the whole quad and making it entirely waterproof. So get yourself some as well. So first let's clean off this board and make sure that we have a good clean surface. So I was just out flying about half an hour before I sat down to shoot this video, and I got my hands on a set of Dominator HD2s, and holy crap, man, does it ever make a difference. Like, I can see so much more out of those things. I've been flying the Attitude V3s pretty much since I started. I got a really good deal on a set, and I was always very impressed, and I love those goggles. They're great, especially for the price point. But man, does it ever make a difference. The HD2s are so nice. I'm stoked to have some DVR because I don't actually have a working HD cam right now. I'm waiting on one on order. So I'd like to get some DVR footage too, because I really miss posting freestyle videos. That stuff is awesome. So okay, I'm pretty happy now that we've cleaned the board and that our solder joints are nice. Yeah, if you are wondering why it's taking me so long to do this build, part of the reason is this little guy right here. This is an EDC spinner by Bluegrass Multirotors. You can find him on Etsy, on Instagram, and also on the fpvchat.slack.com. And man, these things are awesome. They just spin for days. They're amazing. So much fun, wasting so much time on that stuff. And if you haven't checked out fpvchat.slack.com, make sure you do. Those guys are great. You can get some help. It's a great bunch of guys to hang out with and talk quads all day long if you want to. So come check us out. Come see us. All right. So I'm pretty happy with how clean and dry this board is. All the solder joints look good. So let's drone dry it up. So yeah, first we shake it a bit just to mix everything together. Nice. It does stink a bit, so don't be sniffing it. It's probably not good for you. And let's apply generously to the top of the board first. And make sure that you get it all the little nooks and crannies all around the solder. Anything shiny you want to make sure that you cover. I just go for the whole board, but I'm trying to get under the wires as well, which is tricky. But yeah, just keep going. You can't put too much, really, realistically. Alright, so we got the top of the board applied. I was pretty generous with it. I'm pretty happy with how much we put on there. That should be good. So let's do the underside now, and same deal, just go nuts. Alright, so last little thing we're going to do is just I'm going to clean off this little board. I'm not sure if you can see it on the camera there, but it's just a bunch of like rosin gunk from doing the soldering. It should come off with just a little bit of love here. Boom, there we go. Still has like these burn marks on it, but that's fine. That's exactly what this was meant to do. It was just meant to be a shield, so it does not matter. Okay. Oh yeah, one more thing. I'm just gonna put a little bit of drone dry on the bottom of this of the flight controller, because I'm getting pretty ready to like solder the two shut. So I don't want to have to come back here and do it again, and I won't be able to get down there. So let's make sure that we get everything down here quite covered. And it's okay if we go over the pins there, because they're gonna be soldered over when the time comes. So yep, get everything in there. Make sure you get all the tiny little components, all the little legs of the ICs, and especially between components that are very close together, so you might have to gob up a little bit more and just let it kind of flow between them. But yeah, make sure you get every little inch. Alright guys, this took a little bit more finagling than I like to admit, but I finally managed to get the stack to sit correctly as I needed to sit, with the wires here bridging the two, and the ESC is good to go. I'm going to do one quick power test just to see if everything powers up and I don't get anything crazy. And we're going to be using my trusty little station here because it is great. Okay, we got one, Cool. That's pretty much what I expected. We're good to go. So now what we're going to be doing is we're going to be soldering the pins. All these pretty little pins right there. So what you're looking for when you're soldering these guys here is nice, even contacts all the way around. So I like to come back and reheat my solder joints and make sure that they're good. Okay. Cool. So I'm pretty confident here that we've gotten it all soldered very, very nicely here. Cool. Excellent, guys. So we've gotten the FC soldered with the pins and the daughter board, and they're married, and hopefully I don't have to do anything else about that. But we actually ended up with a fairly short stack. I'm very, very, very happy with that. That's a pretty tiny little stack. It's definitely the shortest omnibus stack that I've been able to build so far. So we're going to do our little ritual of cleaning and doing some drone dry on the parts that we've already soldered. And then we're gonna hook up the motors, test that, make sure that it all works. We're gonna put the transmitter on, test that, make sure that it works. You might be asking yourself why I haven't put an XT60 on this guy yet, and that's because up until I'm ready to say that this is a solid electric construction on the quad, I prefer to test everything with the power supply, and it's easier to do so if you have naked wires to work with. So I won't be putting the XT60s until this build is pretty much rocking here. Okay guys, so we're getting ready to solder the motors to the ESCs. We have them all positioned in place. I'm going to tin all the motors and just put a little bit of solder on them. Alright, that's it. Coolio. So we have them all tinned, and let's get started with the wires. So I'm just very quickly here cutting a number of wires down to reasonable-ish sizes that I can work with, and that'll give me some breathing room. Alright guys, so I've gone ahead and chopped the wires down to manageable sizes, and I added a crap ton of solder to the end of it so that we can start tacking them on to the motors. So this should be a fairly simple yet operation of just like tacking them on one by one, and I'm going to be using my friendly little tweezers here to make sure that everything goes smoothly and easily. My tweezers betray me. Cool. Got one wire down. As you can see, I've been very generous with the amount of solder that I left on these wires because I wanted to have lots to work with. Boom. So yeah, that's one motor down. There we have it, guys. So the motor wires are done. You can cut them nice and short. You don't have to worry too much about fucking it up on these motors, because if you do, you can just unsolder that wire and get a new one going in there. So I like this combo a lot. Got two. Let's see if we can get the third one. Oh crap! Yeah, baby. There we go. So those ones there are already pretty much good to go. I'm just gonna do a little quick twist-a-roni. And then we'll do the opposite motors. Alright, so we finally found one that's going to be a little bit tricky to remove. So I'm just going to use an X-Acto blade here to get it started. There we go. Silicone wires are a beauty. Alright guys, so we're just gonna tuck on these wires here. There you go, so one motor down. These are some really short wires, they're kind of hard to work with. Cool, so the clockwise motors are done. That was pretty straightforward and easy. Now we're going to do the counterclockwise motors, and to do the counterclockwise motors, as I mentioned before, we're going to be reversing the direction on the hardware side. So right here, we're going to use the wires themselves to reverse the motor rotation. So I'm just going to reverse two of the middle leads like that, pretty much. Now we're going to do the middle wire. I just reheated the solder because I wasn't too happy with how it was looking. I wanted to make sure it was a good solid connection there. Finally, the last wire on the motors. And there we have it, folks. The motors are wired. So now we're gonna try to turn it on and see if we get the proper ESC tone from the flight controller. That's a beautiful noise. So we've got our ESCs connected. They powered up properly. We got the tone out of it, so we know that the ESCs are good to go and they have signal, and all the work we've done so far is excellent. So the next thing we're going to be doing is actually soldering on the receiver, as well as the video in and video out for the OSD, and getting the camera and all that stuff hooked up. Before we do that, I'm just going to disconnect this off, and we're going to clean up these solders that we just did, put some drone dry on it to make sure that we're good to go. I'm going to put some drone dry on the pins under here as well, because we soldered out before and we didn't reapply. So we're going to make sure that everything's coated before we move on to the next step. So just hold on a sec. Alright guys, now that we have the wiring pretty much done and the drone dry applied, we are going to move on to doing the receiver. So I have a brand new receiver here that I'm going to be using. I have been using the Radiolink controller and receivers since I started flying pretty much. I'm very happy with the Radiolink. The gimbals actually feel a lot nicer than the Taranis in my opinion. And so far I haven't had any issues with excessive failsafes or anything like that. This is the receiver right here. It's very simple. It has one dipole antenna instead of having two diversity single pole antennas, which is an interesting choice, and so far has worked excellently well to me. It is S-Bus, and it's super small and super light, so it should fit nice and easy in here. So I'm probably going to sit it like right on top of the FC, and then the VTX can go on top of that. So before we go further with that, I like to prepare my receivers. So what I do is first I cut this off because this is not going on a B rotor, so I'm not going to need that. And then we're going to remove the shrink wrap. Remove the shrink wrap. Now a couple of things that I like to do while I'm here is to put a tiny bit of hot glue under there and a little bit of hot glue on here, but I'll do that after, just after I put the sheathing back on top of it. So we're not going to be doing much to this except for applying some drone dry to make sure that you don't lose radio contact no matter the weather. So shake it up and we'll put some drone dry on the whole thing. Nice and generous, get every little nook and cranny. Make sure when you have components that are kind of bent over that you squeeze it underneath to get it all over evenly on the surface, and make sure you get the legs of that of those through hole components. Cool. So we got that side. Let's do this bottom side here. Same thing. Nice and generous. Coat the whole surface. Okay. Now we're just going to let this dry for a second. Won't take very long. Give it to the jaws of justice here to hold it in place. And we're going to need some shrink tubing to fit over it. So I like to use white shrink tubing because you can still see the LEDs through it, and it'll match nicely with our current paint job here. So let me get some scissors and let's cut this down. So I cut it a little bit bigger than it needs to be because it is going to shrink. And that means it shrinks almost in all directions. So, cool. Right. before doing this, actually, I'm just gonna very quickly bind it to my. Perfect. So I have it powered up by the power supply right now. And just before we go ahead and put the sheathing on top of it, one of the things that I like to do is to switch it to S-bus mode. There you go. So purple means that it is now on S-bus on the radio links. And the other thing that I like to do as well is take the opportunity to pair it with my radio, and that way it is already paired and good to go, and I don't have to worry about that later. So we have the radio link here. So all we got to do is press and hold that button until it starts blinking. Okay. Turn on the radio and wait for solid light. And we got solid light. I see it on my RSS that we are connected, so we're good to go. Turn that off. Okay. Now that we've done that, we have it paired to my radio, and we know it works, and we have it in S-bus mode now. We can put the little shrink tubing sheath on it. Just like that. Got it protected once more and drone dried. And I'm gonna plug in my hot glue gun, and while that waits, we're gonna start getting the wire soldered to the board. So my plan here is quite simple. It is basically gonna sit on top of the flight controller with some double-sided tape, most likely, just to hold it in place. And I don't foresee any problems with that, so we have a nice short little stack. And the LEDs are on the top here, so I'll still be able to see it. Another little thing you want to do when you use this type of shrink wrap is you probably want to cut and expose the little button, the little momentary push button, with just a little bit of care using your blade. Cut and lift it off, because it kind of holds, when it shrinks, it holds the button down. So when you go to turn it on, it'll be trying to bind itself with something, and that's no fun for anybody. So just test the button by pressing and seeing that I can have that tactile feedback of the click, and it clicks back, so we're good to go on that front. So glue gun is warming up. So the way that the pinout works on the Omnibus is that the closest pin to the inside of the FC is actually your signal pin, so these are all signal pins, and that's your 5-volt pin, and that is your ground pin. So that's how we're going to wire it here. So we don't want a whole crap ton of extra wire, just a little bit, because we want to be able to work on it fairly easily. So I'm kind of just going to chop off that nasty bit at the bottom there. I'm going to try to order them the way that they're going to go in. Just basically like that. Signal, 5-volt, ground. Okay, so we have the leads exposed. We're going to tin them just a little bit. I don't want to make them too fat that they won't fit through the holes. Just a little bit. Gotta be careful with these wires because they do melt very easily. You don't want to keep your soldering iron on them for too long. Just a quick little dab. I'm actually going to trim these down a little bit. I made them a little bit too long. Just need to like cut off like a millimeter or so. Okay, now that we have these in a more manageable state, I'm going to start by putting the signal wire in there. Just get some solder on it. Boom. Signal wire's in. Put it in there and come back with the soldering iron. And now, lastly, the ground pin, the very last pin, the closest one to the edge of the flight controller. Right there. Cool. So we got the receiver all good to go here. Fit nicely. Perfect. I'm gonna plug it in real quick to see that it powers the receiver. There we go, we got the tone, we got it powered, and we got the receiver powered as well, so we're good. Before we move on to actually installing the FPV gear, what we're gonna do is put an XT60 on this wire, and then we are gonna be doing a little bit of testing on Betaflight to make sure that my motors are wired properly and that they respond properly. So let's get going on that. This is actually one of my least favorite parts of building. I kind of hate putting XT60s on. I always burn my fingers, and it requires so much heat for them to like actually stay there. But nonetheless, it needs to get done. I'm gonna go with black for this build because why not? Alright, I done fucked it up. See why I hate doing XT60s? They are a fucking pain. Okay, so I actually ended up melting that one, so let's try another one. Twice is the charm. Alright guys, that was a little bit of a struggle, but I did get the XT60 connected properly with the plus and the minus all set up, so I'm just going to slide these heat shrink covers over top. We'll get them heat shrinked in. Alright guys, this has cooled down a little bit. Let's plug in its first LiPo, and let's hope for no fire. Let's see what happens. Contact. Beauty. So everything seems to be working just fine so far. So the only way for us to ascertain that everything is properly working is to move on to the computer and test the motors, make sure that that stuff is working. So we're going to do that right now. I'm not going to bother with flashing and any of that stuff right now. I just want to make sure that the motors are working. I'm not going to be flashing BL Heli, sorry, but I am, however, going to be flashing Betaflight onto this board because it does not come with the Betaflight. Beauty. We are flashed. Okay, so I'm just going to reboot the board real quick. I'm going to connect to it, and then I'm just going to set the FC orientation, and then we're going to go ahead and test the motors on the motors tab. No, actually it is good to go. We are perfect, so I don't need to change orientation at all. So let's go to the motors tab. So I'm going to do a quick just test to see if the motors are in the correct place. So we're going to connect. We're connected. Now I'm going to go motor 1. I expect this one to spin. Turn on. Good. And 2. Perfect. 3. And 4. So all our motors spun. We're good. I'm just going to crank up the master a little bit to make sure that they're spinning in the right direction. So now that we're happy that the motors are spinning properly, I'm going to move on to the next part, which is actually doing the FPV portion of it. I'm not going to do the flashing of the BL heli or the actual calibration of the SEs until later, because there's really no point. I just wanted to make sure that the wiring that we've done so far is accurate. We can quickly check the receiver tab here, and I can turn on my radio and we can see whether or not the radio is also receiving. Right, so yeah, I need to set up first. So configuration. It's a bit of a pain in the ass sometimes to get the setting to stay. I don't know, I'm probably doing something wrong. There we go. So our receiver tab is good. I can see the bands changing, so I'm just going to give myself some dead band here because I always do. Cool. Perfect. So that pretty much covers the drivetrain or the power plant of the drone we've wired so far. We got the radio hooked up, we got the motors hooked up, and they're all spinning properly. So we're looking pretty good here, guys. We basically just need to do the FPV part of it, and then we're pretty much ready to get this thing hovering, and very soon a Maiden. So let's get moving on to the FPV portion of today. So unfortunately I had a little malfunction with my camera and I lost the footage where I actually did the wiring for the video transmitter on this build. So I'm really sorry about that. I'll go over it right now really quickly so I can explain how I set it up. And to make up for that, I'm going to show you guys how I prepare VTXs for these types of builds. So let's just go over the wiring really quickly. So right here we have the camera harness. Okay, I have that wired to the plus minus of the VTX. So the VTX is going to be feeding the camera 5 volts. The VTX is being fed 12 volts through this shunt over here, which is just a JST. I like having a JST on my VTX because I can very quickly swap them out, or I can very quickly turn it off in the pit if I need to do some work to my drone while there's races going on. So I went with the JST. I find it pretty easy. It's a good solution. It's just going to tuck right there next to the capacitor and be good to go. Oh yeah, that's another thing. I added the capacitor. That was also not part of the build over there. I put some hot glue to just hold it there nice and tight so that it won't be flopping around or anything like that, and it looks pretty solid. The capacitor is very important, especially with these motors. I find that without it you're going to get like really bad video, so make sure you get a capacitor in there. It'll help you out. So the camera, as you can see, has a very short little wire because it's going to be pretty much that low, and that wire is wired to the video in, which is the pin. There's a series of 6 pins on the right side of the FC, and it's the one closest to the nut and closest to the inside of the FC. The one that goes to the VTX, which is the video out, is right over here on the outside, and they are pretty much lined up. And when I was soldering this guy, I didn't realize that it had actually gone through and melted into the signal wire from my ESC. So the first couple of times I powered it up, it did some really crazy shit, but luckily I figured it out, just patched it up, and we're good to go. So that's the video, guys. It's pretty much hooked up. There's not much to it. The camera's going to hook up right there, and it's going to sit right in there. So we're looking pretty good. We're close to getting it to the point where we can hover it. So let's get the VTX set up. So I have decided to go with my original idea of having the VTX out of the bottom. I crashed one of my drones yesterday, one of the ones that has antenna mounted out the top, and it just shattered. So I figured that I'm just gonna do my thing and get a little life out of this drone. So first thing I do is cut the frickin' film off of the VTX, and that should bring with it a lot of this hot glue that I put on. Cool. So I'm not too worried about this this pigtail here because we're gonna replace it. So I'm just gonna cut it right out. So usually what I like to do is I'll snip the signal wire first because I don't want to screw that up. We only have one pad for signal, but we have a few pads for ground. And then I basically snip the ground and I desolder the other one pretty quickly here. Should take no time. There we go, just like that. So we got the pigtail out. I'm just going to clean the solder, the old solder from the VTX that we have right now. I guess I should probably use the actual thing that I built for this purpose, right? Instead of messing around with this crap. Cool. So we got that side cleaned up. Pretty damn good. I'm not too worried about the other side. So we're just going to tin the pads on the VTX and get ready for the new pigtail that we're going to solder. There we go. So we got the 3 pins ready to receive the pigtail. So the pigtail preparation is actually pretty straightforward. I have the pigtail that I'm going to be using right here. And the way that this is going to work out basically is this is going to come out of the VTX and go right under here. Just like that. So it'll go out of the VTX and right under here, just like that. And then the antenna is going to pop out right at that end over there. We actually don't need the lock nut in this thing here. It's not needed. This antenna is just going to go right there. Okay, so that's basically where the antenna is going to come out of. That's the plan. So the VTX is going to be right about here. It's going to be pretty close. Okay. So now that we have measured it out roughly, we can cut. So I figured that I need about that much length on my VTX here, on my pigtail, to get it to work perfect. So I'm going to snip it right there, give myself just a little bit extra. And if you've done SMA soldering or pigtail soldering before, this is pretty trivial. You'll be familiar with this already. So what you want to do is you want to remove this pink sheathing crap. And give yourself enough to work with that you can get enough sheathing to do the ground, because the sheathing is the ground. So we remove that. And we expose the sheathing like that. So the other thing that you want to find out is, so the VTX is going to go like this, and you're going to be having it twisted this way. So this is sort of the twist that is going to happen. So you want to make sure that you're kind of doing that first, so that you already know which direction in rotation this part needs to be to allow that to do that with minimum strain. So in my case, it's like this. So I'm going to pull it to the side, perpendicular to, parallel to what I decided is going to be the orientation. And you pull the sheathing back, pull it back, and pull it down to expose the core. And as you expose the core, you can start twirling this all this loose wire. So that is your ground right there. Okay. So it's going to go like that. It's going to go like this. So now I'm just measuring the positive lead, the middle lead. First I'm going to expose it, but make sure you leave a little bit of white over there. So you don't want these two touching. Make sure you leave a little bit of white and a little bit of the plastic insulator. It is very, very, very necessary. Alright, so now we're just doing the ground. So we tack that first one on. I'm going to tack the second one on over here, and I do it crisscross, so one on the front and one on the back. All of these side pins right there are ground, so you can use any of them. Anyone that you can reach, you're good to go. If you ever break a VTX, you can fix it this way. So if you rip the antennas out, as long as you still have pads in those areas there, you're pretty much golden. I like to throw some solder on all around the ground area, because that prevents any wispies from just being thrown all over the place there. And there we have it, folks. Just like that, we soldered a new pigtail VTX to our VTX, and now we're just gonna do a quick little test, just to make sure that it's still transmitting and everything is good to go. Hey, look at that. So we've got video, and it's working perfectly fine. It's a nice clean signal, so we're good to go. We're just gonna finish the ESC treatment here, make sure that it's waterproofed and anything else, and then we're basically just gonna start closing this thing together and getting ready to frickin' hover, guys. This is exciting. I'm getting excited. This is gonna be good. Okay, let's put that away. Okay guys, so finishing up the VTX is actually a pretty simple process here. So as always, whenever we solder, we clean. Solder, we clean. I don't think I'm gonna need the soldering iron anymore, because I think we're done soldering. Isn't that exciting? The hard part of the build is over. Beauty. Alrighty guys, so, and of course, so I've been calling this drone dry all along because that's what the bottle says. It says drone dry. However, I found out yesterday that drone dry is actually a bagpipe moisture control system. So they've renamed the product since then, and the new bottles are going to be called dry drone. So dry drone, that is what it is. I'm an idiot. I've been calling it wrong all along, even though the bottle says so right here. Should have known better. Anyway, dry drone. Got it? Cool. So let's dry drone this shit. Dry drone. So again, liberal applications everywhere. We're drone dried, or dry droned, Jesus. Okay, so dry droned. It's good. Now we're gonna use this funky shrink wrap stuff that I got on eBay randomly one day. I bought it, I thought it was something else, I thought it was for ESCs, but it turned out to be this stuff, and it actually turns out to be the same stuff that they use on the actual VTXs, so it actually makes it look like it came from the factory, even though it didn't. Ha! Aha! I just remembered what we forgot. A buzzer! I know some of you guys don't use buzzers, but to me that's crazy. So one thing I learned from my previous experience soldering over there for the video is that you want to move your signal cables out of the way, because they'll very easily melt through it, and then you will have some weird shit happening, and you will be like, what in the F did I do to my build? So to avoid the panic that I just encountered, Okay, this is a very straightforward one again, guys. So there's on this corner right here next to the boot button, there's a buzz plus minus, so we're just gonna do that. Cool, so now we have our buzzer wired up. Yep. So buzzer's good. And now we can move on to gluing it into the back there. And we're going to start closing everything up, putting the TPU bits and putting the parts all together, as well as securing everything with zip ties and putting Loctite on the screws. So we're getting pretty close to hovering, which is sweet. Okay, so for the buzzer, all I'm really going to do is sort of like hot glue it back here so that it sits against the frame and just chills there. And it'll be glued to the frame essentially, which should be fine. Right, so I should probably heat up the hot glue. And while we wait for that to happen, we can start zip tying the ESCs and stuff like that, because it's going to take a little while for the hot glue gun to heat up. So I'm just going to do one at a time here. Just grab my preferred zip ties. Okay, so we got some zip ties there. We're also going to retighten all the screws to make sure that the frame is solid and that the motors are also solid. I'm going to put some blue Loctite on the motors too, because I don't want vibrations knocking my motors loose and then things coming flying off midair. That would be not good. Also, just a little tip, when you're cutting zip ties, if you cut them this way, a lot of times you end up with like a little sharp bit, but if you cut them this way, you usually end up with a nice flush cut. So I like to do that when I cut my zip ties. Okay, let's start tightening the bottom screws. We'll start with the stack screws. They should be pretty tight already. Yep. This one's pretty tight. Cool. Now let's tighten the standoffs. Actually, this might be easier to do when we have the two halves holding each other. These are pretty tight already. Cool. So now we just have to finish putting the screws on our motors and getting blue Loctite on this whole thing. I'm just going to use a little piece of paper here to spread my Loctite onto. You could use blue or red Loctite. The main difference being the holding power. The red Loctite is very, very, very strong, and it'll almost form like a resin around it that'll hold that screw in place quite strongly, but it also means that it'll be a little bit harder for you to get it out. Sometimes you need to hit it with heat or something like that, but so I'm not going to go use that. I just need it to not vibrate loose too hard, so I'm going to go with the medium strength, which is the blue. Make sure you shake it up before you use it, because sometimes it separates a little. Okay, so all we're gonna do is put a little bit right there, and then we can dab our screws and get them installed. You just need a little dab, don't need much. It'll spread itself out. I'm not going to fully tighten them yet. I'm just going to set it there, and then I'm going to tighten them in a cross pattern, make sure that the motor sits well, and I'm not putting more torque in one motor versus one screw versus the other. So it's always good to do a cross pattern when you're tightening screws that are laid out in such a fashion. Okay. See, I just had these like barely finger tight. Okay guys, so now we have the screws treated with Loctite, and they've been just slightly tightened in here. So now I'm going to do a cross pattern for final tightening, which is basically like I'll pick one and I'll tighten it until it feels tight, and then I'll go across, and then I'll tighten that side too until it feels about the same pressure, and then I go top, same thing, bottom, same thing, and then I repeat until I'm happy with the way that the screws feel. And you don't need to add a lot of pressure, just a little bit at a time. Okay guys, so the screws have all been tightened in the bottom here. and I'm feeling pretty confident that these motor screws are very nicely tight. So I think our hot glue is warmed up now, and we can finally glue on the little buzzer back here underneath this little crevice, and we'll put on the TPU parts and we'll start closing this guy up. Patience almost ready. Yeah, if I break the rear arm, I'm gonna have to remove the buzzer, but I'm really not too concerned. I don't think I'm gonna be breaking any rear arms. And if I do have to remove the buzzer, it's not that bad of an operation, guys. And there we have it, folks. There is our buzzer. It's nicely tucked away in the back here. It should be pretty safe. So okay, time to check out and slide on the TPU parts, get the camera in place. Moment of truth. Right. Alright, so let's get these TPU parts slid in here. So I'm going to mark the TPU parts right now too to see where and if I need to cut. Yeah, okay, that much I figured. Okay, so on my build in particular, I need to remove that much, so about 2 millimeters worth of material. Before I remove that though, I'm just going to take a quick picture here to show the Detroit Multirotors guys what happened, because they're going to want to know. Okay, so we're gonna have to cut the TPU part a little bit to fit over my wires. So I basically need to remove this bottom band right here. It's already kind of coming apart, so it's gonna be pretty easy. I'm gonna cut it up to there. And over here as well. Cool. I hope it doesn't affect the structural integrity too much, but it should now fit over my wires. Yes, pretty much exactly as I wanted it to be. Cool. So I made a cut that is the width and of the USB port right now, very carefully. I guess I missed this when I cleaned it up the first time. There's just a bunch of crap, little wispy stuff, and it won't let the thing slide easily. And over here too. Oh, come on. There we go. Okay. So let's finish cutting that opening for the USB port. One problem that I see here that I'm going to have for sure, and it's going to be annoying, is changing channels on the VTX. Unless maybe I can mount it in this direction. And in that case, perhaps I can still get to the button somehow. Yeah, that wouldn't be the end of the world, you know. Not my favorite way to mount VTXs, but I think this is gonna have to do, you know, so that I can change the channels, because once I close this up, man, it's not gonna be a lot of room here. Alright. Okay, so we have our camera. I'm going to go ahead and connect the wires to it. And now I'm going to try to position it where it should go. Looks about right. Let's try to get a screw in there. Okay. Actually, this looks like it might actually work. I think the trick is just not to tighten it too much, because you don't want that. Hey. Now my question is, will it hold? I'm just kind of gently tightening it up here because I don't want to go too crazy with it. Cool. Okay. We have our camera. We have our wiring for the PTX. Almost ready here, guys. Let's make sure that this still fits okay over top. Looks good to me. That's not going to go anywhere. Okay, so the last thing we're missing here, guys, is just a VTX. So I'm going to stuff the wires in there. Plug it in. And I'll leave it plugged in. I think this is where it has to sit. So actually what I'm going to do is use a tiny little bit of double-sided tape on it, and then I'll zip tie it to hold it together. And I really like this gray 3M stuff. It works very well. It's very malleable, so it kind of like conforms really nicely to whatever you're trying to hold together. It's almost like a paste. It's weird. Closer and closer to hovering, fellas. So I'm just gonna put it down there because I still want to be able to see the LEDs, and I still want to be able to get to that button right there. And then I'm probably gonna put one more back here, just a tiny little strip. I'm even gonna cut the strip in half. Okay guys, so the way I have it mounted, I can still get to the button right there, which is going to help me out on race days and stuff like that, if it survives that long. Another thing you gotta watch out for is where you're gonna put. Alright guys, we got the VTX zip tied in place. We are moments away from shutting the drone. And then I'm gonna be installing the antennas, the receiver antenna and the transmitter antenna. And that's gonna take no time at all, it's just some zip ties. So here we go. We have mating. It mates, it closes, despite it being one of the tightest builds I have ever worked on. This was not easy. I would say not quite easy. I probably picked the wrong FC for the job. I should have gone with something like a DTFC or a Combini or something that has everything in one single board. Or alternatively, I could have gone with something like the Pico BLX. It does have holes for smaller FCs. You can see you can mount them there, no problem at all. I'll show you in 1 second here on the underside so that you can see what I mean. So I'm pretty sure, so here is the standard FC spacing, and I think these might be for a smaller one. I might be wrong. I'll check on it and put it on the comments when I do know exactly what they're for. So we just have to pop off these 2 screws. Like, oh crap, this one's tight. And then we just put this little plate right there. I guess you can change the direction of it if you want to, which is kind of cool. So yeah, we're going to use all the parts in this drone. It's just that their use is going to be a little tiny bit different than what we originally expected. There we go, fellas. So we need another piece of that stuff. All right, here we go again. This should be a way better solution. So remember, stuff's a little bit malleable while it's warm, so if you play around with it a little bit just before it cools down, just be careful because you might burn your fingers doing it. It's pretty hot, but if you do that, boom, there we have it. Now it's much better, much better. So there you go, guys. We got the build complete, finally. So all we're gonna do is plug it in to make sure that everything still works and that I haven't broken anything. And then I'm gonna flash a new beta flight. We're gonna figure out the OS. Actually, we're gonna flash a beta flight. We're gonna configure my radio to make sure that we have everything ready to go for a hover flight. Okay, so just stay tuned, and we'll be right back. New battery. So there we go, I booted up, we're good to go. Everything seems to be working just fine. So let's move on to the configuration that we need to do to be able to get this thing hovered. Alright guys, so we've got it here. I put some nice dowel props, the clear Q5040s I think they are, and we're about to just hover this guy. I did a little bit of configuration which I'm going to run over in the next video, but let's make sure that this thing hovers and then I can move on to the Maiden. Yeah, it's getting exciting! Alright, so it hasn't flown off and killed anybody, which is a good sign. Pardon me, but since I'm going to be flying from behind the camera, I need to have the rear of it because I am a terrible line of sight pilot. Hit arms. Yeah! We did it! It hovers, guys! It hovers! So I'm probably gonna go Maiden this guy today, and I'll get you guys some DVR footage, and look at that, all the pretty... Hey guys, so we're out here today, the field that I usually fly at in London, Ontario, and we're gonna be Maidening the WP17. So if you've been a company so far, we've built the WP17. Here we have it. Looks freaking awesome. And we're about to maiden it and see how it does. I have done nothing to this build so far other than configuring the radios and making sure that I can arm and disarm. No PID, no OSD, everything else has been left as it is. So you will be seeing DVR footage of this drone because I don't really have a camera mount for it right now. So I hope DVR is okay. I think I'm going to get actually pretty good quality video. So stay tuned, check it out, and we'll be back as soon as it's
Hey guys, so as you can see, it's pretty windy here. You can probably hear some of the wind. I just have a run cam. The sound is not great, so if you're hearing some wind, I'm sorry. We just successfully Maidened the WP17. I ended up putting 2 batteries through it. It was freaking awesome. This thing has so much power and it feels so nice. Stock PIDs on Betaflight and this frame go out pretty damn well. There's a little bit of nodding when you drop the throttle from like going really fast, which is fine. We're going to address that in the next video about tuning. It's not quite as responsive as I would like it to be, but it's pretty damn close. And you'll see in the footage there, despite it being a very windy day, there's not that much prop wash. It did awesome. So I'm excited. Please make sure that you subscribe to the channel because the next video is going to be all about tuning this guy, and we're going to see how well we can make it fly. And I'm going to be going in a fair bit of detail about how I do my tuning, which is it's mostly feel for me. Everybody has their own way of doing it, and I hope that you can learn a little bit from what I do as well. I hope that this video series has been informative so far. I know that this is far from the best build video out there, but if you have some comments, questions, or concerns, make sure you drop me a line on the comments or send me an email or find me at the fpvchat.slack.com. I'm a friendly guy, I'm not going to bite you, and I really, really appreciate any feedback you guys can give me. So I hope you enjoyed the build series, and I'll see you guys next time on the Loose Transistor channel. Take care.